Hi again, my name is Gene and I'm a new mentor for high school robotics team FRC 714 from Newark, New Jersey. This video series is about how easy it is to program FRC robots in Python, the language of many modern apps and most AI products. Previously, we wrote simple code for driving different subsystems of a robot. And if you're not done watching those videos yet, please come back and watch them first. Because today we finally will connect different robot subsystems into complex and useful behaviors, commands. Our first command will be quite useful for any FRC competition season. Driving to intake a game piece. What we want to do is we want to be able to make it so when the pilot pushes the button, robot does the whole thing on itself. Drove up, picked up a note or another game piece and stopped. While the button is still being pushed, operator is not making any decisions. Can you make a guess? How many subsystems are needed to make a command like this? That's right, 2. You need intake and you need drivetrain, 2 subsystems to make a command like this. Let's get to it. In the description of this video, I have put a link to this web page that has a bunch of useful examples. So I'm going to put this link into my web browser. Scroll to the bottom of this web page where we find examples of complex behaviors, commands. And the first command example here is a pick up command, which will make the robot drive up to the game piece and pick it up using intake. Let's see what's inside. Here is a code snippet for a command to pick up a game piece. However, it is important that your robot has an intake subsystem already in its code. So what it means is, if I go to the code of my robot, which is in the state of where we left it after the shooter video, and I open subsystems folder, there must be intake subsystem already there. If not, please go back to the video about the intake subsystem and make sure that you have it. What we need to do next is we need to add a file commands/pickup.py. So we're finally adding commands to our robot. I'm going to create a directory, commands, and inside of that directory I'm going to add a Python file called pickup.py. Now, here is the code of a command to drive up to the game piece and pick it up. It's really short and we're just going to go through it. I'm gonna copy this code to my PyCharm to pickup.py, and let's have a talk about what is needed to define a new command. So first of all, the command is called pickup game piece. So this is the name of the class which defines the pickup game piece command. Pickup game piece is a command. In order to construct such command, which is to call the init method, init function, you need 2 subsystems, as we discussed. You need an intake subsystem and a drivetrain subsystem. And also, you probably want to specify how fast you want to drive up to the game piece that you're about to intake. So the third parameter is the driving speed. Now, every command in WPILib really has 4 functions that you must define. You must come up with an idea for what should the command do. when we are starting it. So, and this function is called initialize for every command. What I want to do when the robot is starting is for the robot to start intaking the game piece on its intake subsystem. Now, the second function that we want to define for every command is execute function, which is what should the robot be doing while the command is running? Well, it's pretty simple. While the command is running, I want the drivetrain subsystem to arcade drive forward with the driving speed that we initially specified. And I don't want any kind of rotation speed while it's driving forward. Finally, what do I want? Finally, function number 3 that we must define is what should the robot do when the command is ending. Well, when the command is ending, I want the drivetrain to stop, which is to be driving at the speed of 0. And I want the intake to stop spinning because the game piece is inside. And the fourth function is the function that actually decides, is it time to finish the command or the command should still be running? If this function returns true, then the robot will assume that it's time to finish this command, to end this command. But if the function returns false, the command should keep running for a little longer. So how do we determine when the robot is done picking up a game piece? All we have to do is we have to ask the intake a question. Is game piece inside? How does the intake determine whether the game piece is inside or not? We can see. We can actually take a look how it's doing. I right click its game piece inside and I say go to declaration. And this is how intake subsystem decides whether the game piece is inside. It checks the state of the limit switch. If the limit switch is engaged, then presumably the game piece has touched the limit switch or has broken the light beam. So we assume that the game piece is inside. So to come back to our pickup command, all we need to do to define any kind of command, simple or complex, is what to do at the start of the command. It's called the initialize function. What to do while the command is running. It's called the execute function. What to do when the command is finished, the end function. In this case, we stop the drivetrain and stop the intake. And how to decide whether this command is finished or not. Here the decision is simple. If the game piece is inside, if the game piece is inside, then we say, yeah, return true. The command is finished. Else, we say, return false. The command is not finished. It must run for a little longer. Okay, so we have a command, but we did not define a button to start this command, right? Let's go back to the web page and let's see. So to run this command on a right bumper button, we need to add this code below to robotcontainer.py inside of configure button bindings function. Okay, let me go find this function. We must go to robotcontainer.py and we must go to find the configure button bindings function. And here, I found it. Now let's go copy that code. Let's go to that web page. I'm going to copy the code that must be added inside of configure button bindings function to bind this new command that we created, pickup game piece, to a right bumper button. Copy and go to this configure button bindings function, and I'm just going to add this code right at the top. It doesn't really matter if I add it at the top or the bottom or middle. Here, time to test this command in simulation. So I'm gonna switch the configuration to sim and hit run. Here the simulated robot is up, and I'm also going to watch what happens in here in the output. I'm going to now switch. So let's make sure that the Xbox controller is indeed joystick number 0. This is my Xbox controller. Now I'm going to switch robot to teleoperated, a simulated virtual robot. And now I'm going to try to press the right bumper button to see what happens. What we see is the intake game piece function was indeed called, according to the printouts in here. Now I'm going to unclick, and the intake is stopped. Okay, we have tested something in simulation. Obviously, we didn't see the game piece actually go into the intake, but that we can do later. So before we deploy this code to the real robot, let's take a look what we actually added to robotcontainer.py. Here we added a pickup command, which is going to use two subsystems: intake, drivetrain called robot drive, and also we specified the driving speed at 0.3, which I believe is reasonable, 30% of the maximum speed that is needed to approach the game piece and to pick it up. Now it is time to connect to our robot over Wi-Fi and to deploy this code onto the robot. This is the Wi-Fi network that we need. I'm going to switch to the deploy configuration and start the code deployment. The code is getting uploaded to the robot, and eventually it says deploy was successful. Let's see if it worked, shall we? Let's start the driver station again. If it was down, it was not start. We can switch the robot to teleoperated. Enable. And prepare to push the right bumper button to see what happens. Pushing the right bumper button. Perfect. Congratulations! Today we have put together our first command that uses two different subsystems, an intake and a drivetrain, to do something complicated and useful, to drive up and to pick up a game piece and to stop in time. And we have bound this command to a button, in this case a right bumper button. Funny how difficult pieces of code become very simple if you break them into small building blocks, right? For example, the whole command here fits on one page. All you have to do for any command is you need to define what to do at the start, what to do while the command is running, what to do when the command is ending, and how to decide if now is time to end. Next up, we're going to define something a little bit more complex, a command with a timeout. It's going to be a command that uses an intake and a shooter to feed the game piece from the intake into the shooter and to shoot it out. Should be fun. See you then.